Good morning. It is Wednesday, April 1st. In Algebra 1 today, you are going to be reviewing 12.3. So in here, we will also be reviewing 12.3, which is your lesson from yesterday. In that lesson, if you remember, you were starting to learn to simplify rational expressions. So this video is just going to give you two more examples of simplifying rational expressions. In one of them, I'm going to hit something that seems to be a pretty common area where people get confused. And then for your assignment for me, it looks very similar to yesterday. You're just going to do another Canvas assignment, where you complete 3 questions. You can do it up to 3 times, and I will keep your highest score. So trying to keep things as consistent for you as I can. So let's look at the first example where we are going to simplify. So your directions on all of these will just say to simplify. So if I am trying to simplify this rational expression. So if you look at the numerator, in the numerator I have just x minus 6. So since that does not have an x squared in it, I know I'm not going to have to do the long kind of factoring. And if I look at x and 6, they do not share a common factor. So that means that in the simplifying step and breaking everything down, that's going to stay x minus 6. But the denominator does have an x squared, and you probably look at it and you realize that that is something by this point that very likely could be factored. So if I'm going to factor that, I am going to need 2 numbers that multiply to be 18, because remember there's a 1 here, so 1 times 18 would be 18. And then those same 2 numbers are going to need to add to be this guy, so they need to add to be negative 9. So if you think through your factor pairs for 18, your 2 numbers that multiply to be positive 18 and add to negative 9 would be negative 6 and negative 3. So that's going to be your factor. So now we are going to, again, I'm going to set up the box method because that's what most of you are using. If you're not using that, that's totally fine. Just make sure that whatever you're doing is resulting in the correct answer. So in the upper left-hand box, we're going to have our leading term, which was 1x squared. And in our bottom right box, we're going to have our constant term, which was 18. Now in the other 2 boxes, this is where you're going to use that negative 6 and negative 3. So we're going to have negative 6x and negative 3x. And now we need to see what we can take out of each row in each column. So in this first row, or first column, sorry, I have a common factor here of x. Moving over, negative 6x and 18, their greatest common factor is 6, and because this is negative, this becomes negative. If the arrow leaves a box, touches a box that has a negative, then the number becomes negative as well. Here, x squared and 6x have a common factor of x. And here, negative 3x and 18, they share a common factor of 3. And again, because of this guy, that will be a negative 3. So this means we can move back over to the original problem, and we can say that that denominator factors to be what we have across the top of the boxes, so x minus 6. And then what we have down the side would be x minus 3. Now, as we look at this, remember that we can cancel vertically or reduce vertically here. So if you see anything that looks exactly the same on top and bottom, that can cancel out. So I can cancel this x minus 6 pair with this x minus 6 pair. Now what's important here to keep in mind is that even though everything canceled off the top, that doesn't mean that the x minus 3 that's on the bottom gets to jump up. When everything cancels out of an area, you technically still have a 1 there. So our answer to this one would be 1 over x minus 3. So again, I just want you to notice that that x minus 3 did not jump up into the numerator. That's very important as you move through. All right, let's look at one more example. All right, let's look at this. So on this one, if you look at the numerator, you probably notice here that it may look familiar, but it doesn't look quite as normal to us as the denominator in the prior problem. And that's because it appears to be missing a term. So it is quadratic, it does have an m squared, but there is a term missing. So that term that's missing is the middle term. So if you remember, at least in my room, I taught you to rewrite these with that middle term there. And if there's no middle term, remember the number that represents having nothing, that would just be a 0. So this is still the exact same problem that we had when we started. I'm just rewriting it so that it looks a little more normal for you as you try to think through what should you do with it. So we need to be able to factor this, is what we would like to be able to do. So the numerator is a typical type of factoring. So I'm going to set up my box over here. For this one, I would be trying to factor and find two numbers that multiply to be -9, and those same two numbers would have to add to be 0. So do you know two numbers that multiply to -9 and add to 0? Hopefully you're thinking 3 and -3. So as we set up our box, in the upper left-hand corner, we would have m squared. And in the bottom right, we would have -9. And then we would have 3m in one of the other squares and -3m in one as well. And now we just need to look for common factors. So if I look here, m squared and -3m share a common factor of m. Here, 3m and -9, they share a common factor of 3. M squared and 3m would share a common factor of m. And as I go here, -3m and -9 would share a common factor of 3. But again, because of this, that's going to become a -3. So as I go back over to my original problem and I put the numerator now in factored form, across the top I had an m and a +3, so that becomes m plus 3. And then down the side I had an m and a -3, so that becomes m minus 3. In the denominator here, I have m plus 3. So that's not quadratic, so I'm not going to have to factor it. And if you look for a common factor between m and 3, they don't have a common factor other than 1. So that means we're just going to leave that denominator alone. So now that I'm doing that, now that I've done that, I'm looking for things that could cancel out. So as you look here, hopefully you notice that you have m plus 3 on top and an m plus 3 on bottom, which means that all we are left with is the m minus 3 on top. So you could technically write this as m minus 3 over 1, because when you clear everything off of the bottom, technically there's a 1 there. But really we don't need to do that. Your most simplified answer would be just m minus 3. All right, I hope these couple of extra examples helped. On your Canvas module, you have an assignment, so make sure you go in and do that assignment, and please do it until you get a good score, because I've given you up to 3 chances to give it a try. Have a great Wednesday, and tomorrow we'll move on to 12-4.